This standard, mass-produced pizza kit is designed for convenience and shelf life, not culinary depth. Its components are structurally uniform and lack the complexity found in a prepared meal. Our goal is to deconstruct these basic materials and use specific thermal and mechanical steps to rebuild them into a plated pizza fritter. On the left is the starting product, a cold plastic tray of raw components. On the right is the target, an elevated structure created by applying specific kitchen techniques to those exact same ingredients. To bridge the gap between these two states, we'll introduce a few pantry upgrades: heavy cream, crushed corn chips, chipotle mayo, and a blend of raw spices. By processing the dough and sauce through these specific steps, we change their physical properties, allowing them to function as components of a complex dish rather than a simple snack. The first phase involves modifying the structural integrity of the provided dough. Roll the dough as thin as possible. This mechanical action overrides its intended use as a thick crust, creating a dense, workable base for the fritter. For the filling, we'll use the included fries. Coat them lightly in olive oil before transferring them to the air fryer. Inside the air fryer, the oil-coated fries sizzle and bubble. This rapid thermal application dehydrates the surface to create a rigid, crispy texture. Securing this thin base and crisping the fries provides the physical foundation needed to support the heavier sauce layers to come. To transform the sauce, we start by dicing the kit's processed meat into uniform pieces. Next, combine the diced meat with the provided cheese, a splash of heavy cream, and a portion of nacho cheese. Folding in nutmeg and artisan Parmesan adds the specific aromatic notes and salt content missing from the original sauce packet. Temperature control is critical. If heat spikes into the red danger zone, chemical bonds break, separating the sauce into oil and solids. Keep heat low and stir constantly. This mechanical agitation locks fats and liquids into a stable emulsion. This controlled temperature and constant movement turns basic, processed ingredients into a cohesive, thick topping. To provide a necessary contrast to the soft sauce, we're engineering a shell of crushed corn chips. First, apply a mandatory base coat of flour to the patty. This primes the surface to ensure the chips have a surface to cling to. Press the crushed chips firmly into the primed patty. This mechanical pressure is required to keep the armor from detaching during the frying process. Fry the patty until the exterior achieves a deep golden brown hue. This visual indicator confirms the crust has set and is ready to be flipped. Once it's out of the pan, tap the surface with a fork. A sharp, resonant crunch verifies that the textural armor is intact and rigid. This shell provides the structural resistance and crunch that the original dough lacked. Assembly begins by using the crispy patty as the foundational anchor for the dish. Layer the components in sequence. First the chipotle mayo, then the fresh tomato slices and the extra pepperoni. Finish the build by pouring the cheese sauce over the top. Its thick, velvety texture evenly coats the layers as it cascades down. For the final polish, add a dusting of red pepper flakes and flax seeds to provide small points of color and heat. The result is a tiered, architectural dish built from the same ingredients found in a standard snack kit. These same steps of layering, texture engineering, and temperature control could be applied to other prepackaged kits to change their final presentation. This transformation relies on specific ratios of heat, moisture, and mechanical pressure to turn a baseline product into a plated meal.